Before we discuss about physics at the GCE A-level, we first need to understand how subjects in JC work. In A-levels, students are required to sit for 4 content subjects. This is in addition to compulsory subjects such as general paper, which replaces English, project work, and mother tongue if applicable. This leaves the content subjects, which includes subjects which students can choose which ones to sit for. At A-levels, content subjects are classified into 3 levels, H1, 2, and 3 respectively. The H stands for higher, and a H1 subject corresponds to the lowest level of the subject offered, while H3 corresponds to the highest. In general, students sit for 3 H2 content subjects and 1 H1 content subject. The student is able to choose which subject to take at the H1 level. H3 subjects are additional and are only offered in JC2. Because of this, we shall mainly be focusing on H1 and H2 physics. While the H1 and H2 formats might seem similar to the combined and pure formats from O-level, there are in fact many differences. Firstly, H1 subjects are counted as their own individual subject. For example, a student taking H1 Geography would have his H1 A-level Geography results solely based on a H1 Geography paper. This is unlike combined science or humanities subject at the O-level, where your final grade is based on 2 subjects. Secondly, in terms of content, H1 subjects have quite literally half the content of its H2 counterpart. Again, this is unlike combined science subjects, whereby around 60 to 80% of the pure science syllabus is included within the combined science syllabus. Lastly, in terms of its overall weightage, H1 subjects have half the impact as compared to H2 subjects. This means that a H2 A grade is worth twice as many points in one's overall A-level results as compared to a H1A. Conversely, a H1B is half as punishing as compared to a H2B. In contrast, as we all know, all subjects at the O-level carry the same number of points based solely on its grade. Now that we have a rough understanding of the H1 and H2 format, let us now discuss some considerations for taking A-level physics. First, we need to appreciate the fact that in the process of university applications, universities generally accept students based upon 2 broad criteria: rank points and subject prerequisites. Just as JC admissions are based on the L1 R5 scores, universities admit students partly based on their overall A-level performance, which is to say, their rank points. However, most, if not all university courses have some sort of subject prerequisite. This refers to the minimum grade of a certain subject which the course requires applicants to take. Otherwise, regardless of their rank points, they would not be eligible for that course. For example, the course Physics and Applied Physics offered in NTU has the subject prerequisites of a pass in both H2 Physics and H2 Mathematics. This means that someone taking either physics or mathematics at the H1 level, or not at all, is automatically not eligible to apply for this course. Fortunately, most university courses allow for an option of prerequisites, in the sense that they merely require a pass in physics or chemistry or biology, or any 2 of them. Hence, we only need to consider the subjects which mandate physics as a prerequisite. While the list is non-exhaustive, some courses which mandate H2 physics as a prerequisite are shown below. That being said, subject prerequisites are subject to change, and some universities do allow students with non-physics backgrounds to take up the courses should they also take up physics bridging modules, as is the case for NUS engineering courses as listed below. Nevertheless, we also need to consider the opportunity cost of taking physics, as, unlike secondary school, there are no triple science subject combinations. This necessarily means that by taking physics at A-levels, you will not be able to take biology at the A-levels, as all JCs require physics science students to take either chemistry, further mathematics, or computing. Fortunately, apart from biology itself, there are no local university courses that require students to take A-level biology as a prerequisite. This means that by taking physics, you only close the door to theoretical biology courses. Yep, physics students would still be able to apply for courses such as medicine and dentistry in local universities. Next, we would be considering how taking physics complements other subjects at the A levels. Naturally, being a study of energy and matter, physics has many conceptual linkages to physical chemistry, which accounts for roughly 40% of the H2 syllabus for chemistry. The topic of atomic structure deals with electronic configurations of atoms, and quantum physics deals with the energy gap between different electron shells. Chemical bonds, such as ionic bonds, are governed by Coulomb's law, which is covered in the topic of electric fields. This is because all chemical bonds are electrostatic in nature. Furthermore, there is the exact same topic appearing in both H2 physics and H2 chemistry, called ideal gas, which both revolve around the qualitative and quantitative aspects of real and ideal gases. Looking at physical geography, the processes of rainfall formation and heat distribution can be better understood as a thermodynamic process, which is covered in H2 physics. In addition, the H2 geography topic of mass movements requires the analysis of forces acting perpendicular and parallel to particles on a slope. This ultimately affects the occurrences of landslides. While in-depth physics knowledge is not required for the aforementioned topics in both chemistry and geography, we can see that the qualitative topics in those two subjects are built upon quantitative physics concepts. It can be said that while not explicitly examined, physics does serve to deepen one's understanding and appreciation of numerous other topics in other subjects. Lastly, we need to consider the minimum indicative cutoff which JCs implement for each subject. Just as each university course may have its own minimum subject prerequisite, some JCs may implement minimum subject grades which students need to attain at the O level to take up a particular subject. While each school may set its own unique cutoff, in general, students need to attain a minimum of B3 for that pure science or an A1 for that combined science to be able to take it at the H2 level. Nevertheless, different schools have different cutoffs, and as such, it would be prudent to simply Google search the subject combination of your applied JC in the year 2022, as demonstrated here by the example of TJC. As a side note, all these cutoffs are still subject to appeal and should only be seen as a general guide. Now, it is time to talk about the actual content for A-level physics and how it compares to O-level physics. Compared to any other A-level subject, physics has the most in common. Physics can be classified broadly into 5 aspects: measurements, Newtonian mechanics, thermal physics, waves, and finally electricity and magnetism. At the A-levels, there's a new aspect of physics which we will learn about, known as modern physics. We shall now take a look at the topics from O-level pure physics, as well as both H1 and H2 physics, and see how they compare with one another. Looking first at Newtonian mechanics, we can see that there is nearly a complete overlap between pure physics and A-level physics. The main difference is that pressure is no longer a topic at the A-levels, and circular motion is a new topic. Now, looking at thermal physics, we observe that this module is completely excluded from the H1 physics syllabus. Between H2 and pure physics, it can be said that while pure physics focuses more on breadth, with the increased number of topics, H2 physics focuses more on depth, with the increased number of learning outcomes per topic, which are not shown here. This is in fact a recurring trend which we would observe more. Again, oscillations and waves module is entirely omitted from the H1 syllabus. In addition, we observe that more qualitative aspects of waves, such as light and sound, have been replaced by more mathematical and quantitative topics such as oscillations, where we would be dealing with more mathematical aspects of waves. Finally, looking at electricity and magnetism, we see that pure physics has more topics than both H1 and H2 physics, if we were to consider the common last topic, that is. While there may be many similarities between O and A-level physics in terms of the topics, what is offered in A-levels contains more breadth and more notably depth. This is the case in both the qualitative and especially so of the quantitative aspects of A-level physics. Now, let us take a closer look at some examples. Making a side-by-side comparison between O-level gravitation and A-level gravitation, it becomes clear that A-level demands much more quantitative rigor. We can see that at A-level, it works upon our O-level knowledge of gravitational fields, whereby in O-levels, we merely need to know what a gravitational field is, but in A-levels, we actually need to calculate the strength of the field. In addition, observe that the new concepts introduced in A-levels, such as gravitational potential in this case, are not entirely alien to us because it is based upon what we have already established in O-levels, such as work done and mass. Having a look at the kinetic model of matter, which A-level focuses specifically on gases, we can see again that the points of focus of O-levels are more qualitative in nature. This is in comparison to A-levels, where our qualitative O-level knowledge is built upon to form quantitative relationships between different variables which we have already learned about, or concepts like molecular motion and kinetic energy. The final comparison we shall make is between O-level electromagnetism and A-level electromagnetism. From our qualitative knowledge of magnetic fields produced by current-carrying conductors and solenoids in O-levels, in A-levels, we are required to know how to calculate the strength of the said field. Nevertheless, this knowledge is not entirely foreign to us because it has already been covered within the O-level syllabus. For instance, the strength of magnetic fields increases with the current and the number of turns. What A-level does is simply to put what we have already been learning into a mathematical equation. Again, we have learnt in O-levels about Fleming's left-hand rule, and in A-levels, we would be required to quantitatively calculate the force produced. Even looking at the formula, this isn't something exactly new, as we already know the variables that we have learnt in O-levels, such as the force, magnetic field, and current. Overall, the number of topics for O-level pure physics and A-level H2 physics are remarkably similar. Of the 20 H2 physics topics, 15 of which have been partially covered in pure physics already, and of the 15, many of which have very similar learning outcomes as we have just seen. However, as mentioned, it is a recurring trend across the topics that A-level focuses more on depth and quantitative knowledge, while O-level focuses more on breadth and qualitative knowledge. That being said, while the increase in the number of mathematical formulae might seem daunting and involve very much more memory to memorize more equations, this is certainly not the case. For H2 physics, a lengthy formula list is provided for all theory papers, encompassing nearly every mathematical formula or minimally variants of it. Remember those new formulae for the topics of gravitation, kinetic model of matter, and electromagnetism? Yep, they are pretty much all here. Between H1 and H2, it can be seen that H1 physics has half the content of H2. Specifically, the modules excluded from H1 are thermal physics and waves. In terms of format, both O and A-level physics are really similar. Both feature a multiple choice question paper, one or more written papers, and a practical paper. The main difference is that there are two written papers, paper 2 and 3, for A-level, while there is only one written paper for O-levels, and that the time allocation for each mark is longer for A-levels. On that note, just as 6091 O-level pure physics features a single practical examination, 9749 H2 physics features a single practical examination, and not the school-based practical assignment, more commonly known as SPA. Now comparing between H1 and H2 physics, the H1 examination lacks a practical paper and only contains a single structured paper. This is consistent with the other science subjects as well. In addition, compared to the data and formulae sheet provided for H2 physics papers, the data and formulae provided for H1 physics papers are far less extensive. Here is a side-by-side comparison. As one might expect, This implies that there will be a lot more memorization required for H1 physics compared to H2. Lastly, here are some miscellaneous comparisons between H1 and H2 physics. School resources. Since there are far more H2 science students than there are H1 science students, it can be assumed that the quality of school resources for H2 physics is far superior to that of H1. We have to remember that in JC, there are no prescribed textbooks and one needs to almost entirely rely on school resources for any given subject. The difficulty of H1 papers. While H1 and H2 physics might share numerous content similarities, the kinds of questions do differ between H1 and H2 papers in Cambridge exams. In general, H1 papers focus more on qualitative and fundamental questions which truly test the essence of one's physics knowledge. Scoring marks from these questions tends to be more unreliable compared to the quantitative and calculation-based questions which are a staple of H2 physics papers. This in fact, and ironically, makes H1 papers more challenging than H2. National distinction rates. Perhaps due to the increased difficulty of the H1 paper compared to H2, the national distinction rate for H1 physics typically hovers around 20%. This is in contrast to H2 physics, which sits comfortably at slightly over 40%. So, for those sitting on the fence deciding between H1 and H2 physics, spend some time to think about the following questions. Which are my weaker topics in physics? Specifically, do I struggle with thermal physics and wave modules? Do I struggle with memorizing equations? While physics is said to be the least content-heavy subject at A levels, H1 physics definitely demands more memory than H2 in terms of memorizing several key equations, which will not be provided in the formula sheet. And finally, how competent am I with the practical exam? While you might not believe that you are the best at the practical paper, at the A levels, the practical paper is said to be the easiest paper to score marks and can actually help to pull up your grade. With the exclusion of SPA, practical skills themselves are no longer examinable, and accuracy only accounts to at most 2 marks out of the 55 from the entire paper, leaving the majority of the paper with really simple calculation-based questions. Now, what if I'm a combined science student? Should I still be taking H2 physics? Well, if your school allows it, it would still be recommended for you to do so due to the ease of the H2 paper compared to H1. However, rest assured that schools do provide bridging modules to help combined science students pick up the fundamentals taught in O-level pure physics. For all these reasons, it would be suggested for all those who are both weak and strong in physics to take H2 physics instead of H1. The sheer amount of calculation questions without the need to memorize any formulas, as well as the fact that the majority of A-level physics has already been covered in O-level physics, makes A-level physics arguably the easiest A-level subject. Most schools only provide students with the weekend to confirm their subject combination. It would be best to decide which subject combination you intend to take before JC starts. And with that, I've come to the end of my sharing. I hope you have learned more about A-level physics and that I gave you some insights. If you have any further questions regarding this topic, feel free to contact us via Discord or our YouTube channel. Thank you for attending this sharing, and see you tomorrow.